They measured the armor plate with calipers, checking the readings 3 times to be certain. 51 millimeters on the glacis, angled back at 56 degrees from vertical. The Japanese engineer wrote the number in his notebook, then calculated the effective thickness against a penetrating projectile. The mathematics were unforgiving. The sloped armor provided protection equivalent to approximately 75 millimeters of vertical plate. He looked up at the olive-drab hull sitting in the examination bay at the Army Technical Bureau's facility in Tokyo. The M4A3 Sherman medium tank had been captured intact in the Philippines in October of 1944, shipped to Japan aboard a freighter that somehow avoided American submarines, and delivered to this warehouse for detailed evaluation. It was January of 1945, and this was the first complete, undamaged Sherman that Japanese engineers had been able to examine thoroughly. The engineer moved to the turret, measuring its frontal armor. 63.5 millimeters, he recorded, significantly thicker than the hull. He examined the gun mantlet, the thick armor shield that protected the main gun's mounting, 76 millimeters at its thickest point. He ran his hand across the cast steel surface, feeling the quality of the American metallurgy. In another section of the facility, a colonel from the Army Ordnance Department watched the examination proceed. He had spent the morning reviewing technical drawings of Japan's newest tank, the Type 3 Shinu, a vehicle that Japanese designers believed represented a significant advancement in armored warfare capability. The Shinu mounted a 75mm gun, the same caliber as the Sherman. It had been designed specifically to counter American medium tanks. Production had begun in 1943 at Mitsubishi's works. The colonel carried a file folder containing specifications for the Shinu. He had been asked to prepare a comparison report, an honest assessment of how Japan's most modern tank measured against this captured American vehicle. The question before him was simple but profound. Could the Shinu compete with the Sherman in combat? And if not, what did that mean for the defense of the home islands? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The answer to that question had implications that extended far beyond technical specifications. By January of 1945, the strategic situation facing Japan was desperate. American forces had recaptured the Philippines. The Mariana Islands were in American hands, placing Tokyo within range of B-29 bombers. The Navy had been shattered at the Battle of Leyte Gulf in October. Submarines had cut the shipping lanes that connected Japan to its conquered territories in Southeast Asia, choking off the flow of oil, rubber, raw materials. The home islands faced invasion. American forces were moving steadily closer. Tsushima would be assaulted in February. Okinawa would follow in April. And after Okinawa, the next step would be Japan itself. The army understood that defending the home islands would require every resource the nation could muster, including armored forces capable of defeating American tanks. This context gave the examination of the Sherman an urgency that transcended normal technical evaluation. Japanese engineers were not simply measuring another enemy vehicle. They were trying to determine whether their own tanks could protect the homeland. They were looking for vulnerabilities they could exploit, weaknesses they could target. They were searching for hope that Japanese armor could contest American armor on anything approaching equal terms. The hope that had sustained them was rooted in the Shinu program. Development of the Type 3 Shinu had begun in 1943 when the Army recognized that existing Japanese tanks were inadequate against American armor. The Type 97 Chiha medium tank, Japan's standard medium tank throughout the Pacific War, mounted a 57mm gun that could not reliably penetrate Sherman armor at combat ranges. Its own armor, 12 to 25mm thick depending on location, offered minimal protection against American 75mm guns. The Shinu was designed to correct these deficiencies. It mounted the Type 3 75mm tank gun, a weapon derived from the Type 90 field gun. This gun could fire a projectile weighing 6.6 kilograms at a muzzle velocity of 700 meters per second. On paper, its armor-piercing performance was comparable to the Sherman's 75mm gun. The tank had frontal armor 50 millimeters thick, more than double the Chiha's protection. Japanese engineers believed they had created a tank that could fight American armor effectively. The Chi-Nu represented their best effort, incorporating lessons learned from years of combat and utilizing the maximum armored protection Japan's industrial base could produce and transport. 166 Chi-Nu tanks were built between 1943 and 1945. None were sent to the Pacific Islands. All were retained in Japan for the final defense. The decision to keep the Chi-Nu tanks in Japan reflected strategic priorities. The army believed that losing the home islands would end the war, while losing individual Pacific islands, however costly, would not. Therefore, the best equipment had to be preserved for the ultimate battle. The Chi-Nu tanks waited in depots and training areas, their crews preparing for the invasion that seemed increasingly inevitable. This was the context in which Japanese engineers examined the captured Sherman. They had confidence in their newest design. They believed the Chi-Nu represented a significant improvement over earlier Japanese tanks. They hoped it would prove adequate for its intended mission. But hope and reality do not always align, and the Sherman sitting in that examination bay would reveal truths that no amount of optimism could overcome. The development of the Chi-Nu had followed a path marked by compromise and constraint from its inception. In 1943, when the Army Technical Bureau issued specifications for a new medium tank, Japanese engineers understood they faced limitations that Allied tank designers did not. Japan's steel production was a fraction of America's. The nation's industrial base was smaller, less automated, and increasingly strained by years of war. Resources had to be allocated among competing priorities: aircraft, ships, artillery, small arms, and armor. Within these constraints, engineers at Mitsubishi Heavy Industries worked to create the best tank possible. They started with the Chiha chassis, modifying and strengthening it to accept a larger gun and heavier armor. The decision to use an existing chassis rather than designing an entirely new vehicle saved time and resources but imposed limitations on what could be achieved. The Chiha hull was designed in the mid-1930s for a tank weighing 15 tons. Upgrading it to carry 50mm armor and a 75mm gun pushed the design to its limits. The Type 3 75mm gun was the Chi-Nu's primary feature. This weapon was adapted from the Type 90 field gun, a proven artillery piece with good armor penetration characteristics. Converting a field gun to tank use required significant engineering work. The recoil system had to be modified to function in the confined space of a tank turret. The mounting had to be designed to allow for traverse and elevation while maintaining structural integrity. The ammunition had to be made practical for a tank crew to handle and load quickly. Japanese engineers succeeded in creating a functional tank gun, but the process took time and revealed challenges. The Type 3 gun was longer and heavier than the 57mm gun it replaced. This affected the tank's balance and made the turret front-heavy. The gun's recoil was substantial, requiring a robust mounting that added weight to an already overburdened chassis. The rate of fire was limited by the difficulty of handling the larger ammunition in the cramped turret space. Armor protection on the Chi-Nu represented a doubling of thickness compared to the Chi-Ha, but this came at a cost. The additional armor increased the vehicle's weight to 18.8 tons, nearly 4 tons heavier than the Chi-Ha. The engine, a Mitsubishi Type 100 diesel producing 170 horsepower, was the same engine used in the Chi-Ha. This meant the Chi-Nu was underpowered for its weight, reducing its mobility and increasing mechanical stress on the drivetrain. The armor itself was rolled, homogeneous steel plate, welded into a hull and turret structure. Japanese metallurgy in 1943 was adequate for producing armor plate, but quality control was becoming increasingly difficult as the war progressed. Access to alloying elements like nickel and chromium, which improved steel's hardness and resistance to cracking, was limited. Some Chi-Nu tanks built later in the production run used steel of lower quality than earlier vehicles, a reflection of resource scarcity. Inside the Chi-Nu, the crew consisted of 5 men: a commander, gunner, loader, driver, and hull machine gunner. This was one more crew member than the Chiha carried, reflecting the increased complexity of operating the larger gun. The fighting compartment was cramped but functional. The commander had a cupola with vision blocks, allowing him to observe the battlefield without exposing himself. The gunner had a telescopic sight for aiming the main gun. The loader had access to ammunition racks, holding 55 rounds of 75mm ammunition. Communication equipment varied by production batch. Early Chinook tanks had radio sets, but as the war continued and radio components became scarce, later tanks were built without radios or with simplified communication systems. This was a significant limitation, as coordinated armored operations require reliable communication between vehicles. Without radios, tank platoons had to rely on visual signals, a system that broke down quickly in combat when smoke, terrain, and enemy action made visual contact difficult. The suspension system was a modified version of the Chiha's bell crank design, strengthened to handle the additional weight. The tracks were 370mm wide, providing adequate ground pressure for the vehicle's weight. The engine could propel the Chinook to a maximum speed of 39 km per hour on roads, with cross-country speed significantly lower. Operational range was approximately 210 kilometers on internal fuel, adequate for defensive operations but limited for mobile warfare. Production of the Chinook began in earnest in 1944 at Mitsubishi's facilities. The production rate was constrained by multiple factors. The factory space available for tank production was limited. Skilled workers were increasingly scarce as men were conscripted into the military. Raw materials, particularly high-quality steel, were in short supply. Components like engines, transmissions, and weapons had to be manufactured or assembled from parts produced at different facilities, creating logistical challenges. The result was a production rate that never exceeded 15 tanks per month, and often fell below that figure. By the time production ended in 1945, only 166 Chinook tanks had been completed. This was fewer than 1 month's production at a single American tank factory. The industrial disparity that characterized the Pacific War was evident in these numbers. Japan was producing tanks as quickly as its industrial base allowed, but that base was simply inadequate for modern mechanized warfare on the scale the Allies could sustain. Japanese tankers who trained on the Chinook viewed it as a significant improvement over the Chiha. The larger gun gave them confidence that they could engage American armor effectively. The thicker armor provided a sense of protection that earlier tanks had lacked. The additional crew member made operating the tank less exhausting, as tasks were distributed among more people. Crews believed they had been given equipment that would allow them to fight with some chance of success. This belief was reinforced by Army training and doctrine. Instructors emphasized fighting spirit, tactical skill, and determination. They taught that properly employed, the Chinook could defeat American tanks through superior tactics and crew performance. They stressed the importance of choosing good defensive positions, firing first, and exploiting the enemy's weaknesses. This training instilled confidence, perhaps more confidence than the equipment warranted. The tanks themselves remained in Japan, positioned at training areas and depots around the home islands. The Army's plan called for using them in the defense against invasion, committing them at critical points to counterattack American landing forces or to reinforce defensive positions. The Chinook was to be Japan's armored reserve, held back from the peripheral battles and preserved for the decisive engagement. Military planners believed this was sound strategy. Every tank sent to a Pacific island was a tank lost, destroyed in battles that ultimately did not affect the war's outcome. Better to keep the armor at home where it could be maintained, where crews could train with their vehicles, where fuel and ammunition were available, and where the tanks would face the enemy in the most important battle of all. The logic was defensible given Japan's strategic situation, but it meant the Chinook would never be tested in combat until the invasion came. By January of 1945, when the captured Sherman arrived for examination, Japanese engineers had confidence in the Chinook, born from technical specifications and comparative analysis with earlier Japanese tanks. They knew it was better than the Chiha. They believed it was comparable to Allied medium tanks. They hoped it would prove adequate for its mission. But they had never directly compared a Chinook to a Sherman, measuring both vehicles side by side, evaluating the real differences in armor, firepower, and design philosophy. That comparison was about to occur, and it would reveal gaps that technical specifications alone could not convey. The examination of the Sherman proceeded systematically over several days in January of 1945. Engineers from the Army Technical Bureau worked in shifts, measuring, photographing, and documenting every aspect of the captured tank. They removed hatches and panels to access internal components. They examined the transmission, the engine, the suspension, the gun mounting, the ammunition storage, the vision equipment, and the communication systems. Each measurement was recorded, each component was sketched. The goal was complete understanding of how the Americans had designed and built their medium tank. The hull armor measurements revealed a consistent pattern. The frontal glacis plate was 51 millimeters thick, but its 56-degree angle from vertical increased its effective thickness against projectiles striking it head-on. Japanese engineers calculated that a penetrating round would have to pass through approximately 75 millimeters worth of steel due to the angle. This was a design principle Japanese tanks did not employ. The Chinook's frontal armor was 50 millimeters thick but mounted vertically, providing no benefit from angling. The side armor measured 38 millimeters on the Sherman's hull. This was less than the frontal protection but still substantial. The rear armor was also 38 millimeters. The deck and belly plates were thinner, ranging from 12 to 25 millimeters, but these surfaces were less likely to be hit in combat. The turret armor was even more impressive, 63.5 millimeters on the front, with the gun mantlet providing an additional 76 millimeters of protection around the main gun. Engineers examining the armor plate noted its quality. The steel was homogeneous rolled armor, similar to what Japan produced, but the American plate showed consistent hardness and no visible defects. They tested small samples with hardness testing equipment and found the steel met or exceeded specifications. The welding was clean and thorough, with no weak points visible in the joints between plates. The overall construction quality impressed the Japanese engineers, who were accustomed to seeing declining quality in their own production as the war progressed. The Sherman's main gun was a 75 mm M3 cannon, a weapon roughly comparable in caliber to the Chinook's Type 3 gun. The Japanese engineers removed the gun from its mount to examine it more closely. The barrel was 40 calibers long, meaning its length was 40 times its bore diameter, giving it a total length of 3 meters. The gun could fire armor-piercing rounds at a muzzle velocity of approximately 619 meters per second, slightly slower than the Chinook's 700 meters per second. But the mounting system revealed significant differences in design philosophy. The Sherman's gun was mounted in a gyro-stabilizer system that kept it relatively steady even when the tank was moving. This allowed the crew to fire accurately while on the move, a capability Japanese tanks completely lacked. The stabilization was not perfect by later standards, but it was far better than nothing. Combined with the power traverse system that rotated the turret electrically rather than by hand crank, the Sherman's fire control system was substantially more advanced than anything in Japanese service. The turret itself demonstrated American design priorities. It was spacious compared to Japanese turrets, providing room for 3 men to work without constantly interfering with each other. The commander had a cupola with 6 vision blocks giving him 360-degree observation capability. He could see all around the tank without exposing himself by opening a hatch. The gunner sat to the left of the gun with a periscopic telescopic sight that provided magnification for aiming. The loader stood to the right of the gun with easy access to ammunition racks holding 97 rounds. Radio equipment was installed in every Sherman, not just one vehicle in 4, as was standard in Japanese practice. The Americans used an SCR 528 or SCR 538 radio set, depending on the variant, allowing voice communication between tanks and with supporting infantry and artillery. The radio installation was professional, with proper mounting brackets, power supplies, and antenna systems. Japanese engineers noted that radio communication appeared to be an integral part of American armored doctrine, rather than a luxury available to only some vehicles. The engine compartment revealed the Continental R975 radial engine, an air-cooled gasoline engine producing 400 horsepower at 2,400 revolutions per minute. This was more than twice the horsepower of the Chinoo's 170 horsepower diesel. The additional power gave the Sherman, despite weighing 30.3 tons compared to the Chinoo's 18.8 tons, comparable mobility. The Sherman could reach 42 kilometers per hour on roads, slightly faster than the Chinoo despite being 12 tons heavier. The suspension system used a Chinoo, vertical volute spring suspension, a simple and robust design that provided good cross-country performance. The tracks were 16.5 inches wide, providing adequate ground pressure for the vehicle's weight. The drivetrain showed signs of heavy use, but remained functional, suggesting good reliability. Japanese engineers noted the ease of access to components for maintenance, with large hatches and panels that allowed mechanics to reach critical parts without extensive disassembly. As the examination progressed, the colonel from the Army Ordnance Department reviewed the measurements and compared them to the Chinoo's specifications. The comparison was not favorable. The Sherman had thicker armor, especially when accounting for the sloped glacis plate. It had a more powerful engine, giving it better mobility despite greater weight. It had superior fire control systems, better vision equipment, and professional radio installation in every vehicle. The American tank carried more ammunition, 97 rounds compared to 55 in the Chinoo. The one area where the Chinoo appeared superior was in gun performance. Its 75mm gun had higher muzzle velocity, 700 meters per second compared to 619 for the Sherman's gun. This suggested better armor penetration at longer ranges, but this advantage was offset by the Sherman's stabilization system and power traverse, which allowed faster, more accurate engagement of targets. In practical terms, the Sherman crew could fire first in most encounters, and first shot in tank combat often determined the outcome. What troubled the Japanese engineers most was not any single specification but the overall design philosophy the Sherman represented. American engineers had created a tank that balanced armor, firepower, and mobility, while providing the crew with equipment that allowed them to fight effectively. The tank had backup systems and redundancies. It had proper vision equipment, so the crew could see without exposing themselves. It had communication equipment, so tanks could coordinate their actions. It had a layout that let 5 men work together efficiently, rather than forcing one man to perform multiple tasks simultaneously. The Chinoo, by contrast, reflected design choices driven by constraints rather than optimal combat effectiveness. Its armor was as thick as Japan could produce and transport. Its gun was the largest that could be fitted to the modified Chiha chassis. Its engine was the most powerful available in Japanese production. But the result was a tank that made compromises in every area, a vehicle that was adequate by Japanese standards but inferior to what the Americans fielded as their standard medium tank. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological impact of this realization on the examining engineers was profound. Many had spent years in tank development, working within Japan's industrial constraints to create the best vehicles possible. They had believed that Japanese engineering skill and fighting spirit could compensate for material disadvantages. They had confidence that the Chinoo represented a genuine advance, a tank that could compete with Allied armor. The Sherman sitting before them proved otherwise. The formal report was compiled over several weeks in February of 1945. Engineers wrote detailed technical descriptions of every Sherman component they had examined. They included measurements, photographs, and sketches. They calculated armor protection values, gun performance figures, and mobility characteristics. They compared these figures to the Chinoo's specifications and to other Japanese tanks. The report ran to hundreds of pages, a comprehensive technical document that represented the most thorough evaluation of American tank design Japanese engineers had conducted. The conclusions section was written carefully, using language that conveyed technical findings without overt defeatism. The report noted that the Sherman possessed superior armor protection, particularly on the frontal arc, where the sloped glacis plate provided effective thickness equivalent to 75 millimeters. It observed that the Sherman's engine provided substantially greater power, giving the vehicle good mobility despite its weight. It documented the Sherman's advanced fire control systems, including the gyrostabilizer and power traverse, which Japanese tanks lacked. The report acknowledged that the Chi-Nu's main gun had higher muzzle velocity and potentially better armor penetration at range, but it noted that the Sherman's superior fire control systems would likely allow American crews to engage targets more quickly and accurately. The overall assessment was diplomatic but clear. The Sherman was a more capable tank than the Chi-Nu in most operational parameters. In a direct engagement between the two vehicles, the Sherman would have significant advantages. The report made recommendations for addressing these deficiencies. Engineers suggested developing improved armor layouts using sloped plates to increase effective thickness without adding weight. They recommended research into power traverse systems and gun stabilization. They proposed improved vision equipment and standardized radio installation in all tanks. These recommendations reflected sound engineering judgment, but they were largely academic. Japan, in February of 1945, lacked the industrial capacity, the time, and the resources to implement major design improvements. The report circulated among Army staff officers responsible for planning the defense of the home islands. Their reactions varied. Some officers focused on the tactical recommendations, discussing how to employ Chi-Nu tanks to maximize their advantages and minimize their weaknesses. They noted that defensive positions could be chosen to negate the Sherman's mobility advantage. Japanese tanks could be dug in, used as mobile pillboxes that engaged American armor from prepared positions at ranges where the Chi-Nu's gun performance was optimal. Other officers recognized that tactical solutions could not overcome fundamental material inferiority. The Sherman was better protected, better armed in practical terms, and better equipped. American production capacity meant that Shermans would vastly outnumber Chi-Nu tanks in any invasion scenario. Intelligence reports indicated that American armored divisions committed to the Pacific Theater had hundreds of tanks, while Japan's entire Chi-Nu production totaled 166 vehicles, all stationed in the home islands. Some officers questioned whether the decision to retain all Chi-Nu tanks in Japan had been correct. Perhaps sending them to the Philippines or Okinawa would have allowed combat evaluation of the tank's actual performance against American armor. Perhaps combat experience would have revealed problems that could be corrected before the invasion of Japan. But others countered that sending the tanks to outlying islands would have simply resulted in their destruction, wasting resources that would be needed for the final defense. The debate was somewhat theoretical because by February of 1945, the strategic situation had deteriorated to the point where tank design comparisons seemed almost irrelevant. American forces were preparing to invade Iwo Jima, a battle that would begin on February 19th. Okinawa would be next, with invasion planned for April. The home islands themselves would face assault sometime in the fall if the war continued. Japanese military planning focused on making the invasion as costly as possible, hoping that inflicting massive American casualties might lead to negotiated peace rather than unconditional surrender. Within this context, the Chi-Nu tanks represented one small element of the defensive forces. They would be committed when American forces landed, used to counterattack landing beaches, or to reinforce defensive positions under heavy assault. Their crews had trained extensively, learning to operate their vehicles and to employ them tactically. They understood they were fighting with equipment inferior to what they would face, but they believed that proper tactics, good positions, and determination could compensate for material disadvantages. The tank crews were not shown the detailed comparison report. They were not told that Japanese engineers had concluded the Sherman was superior in nearly every measurable category. They were given tactical training and doctrinal instruction that emphasized what they could do rather than what they could not do. This was perhaps a kindness, allowing them to maintain morale and fighting spirit. But it was also a reflection of the impossible situation Japan faced, asking soldiers to fight with inadequate equipment while maintaining the fiction that victory was possible. The engineers who had examined the Sherman and written the report understood the truth. They knew that the Chi-Nu, despite representing Japan's best effort at creating a modern medium tank, was obsolete before it ever saw combat. They knew that American industrial capacity had produced tens of thousands of Shermans, while Japan struggled to build a few hundred Chi-Nus. They knew that the gap in quality and quantity was too large to overcome through tactical skill or fighting spirit. Some engineers proposed emergency modifications to the Chi-Nu design. They suggested adding supplemental armor plates to increase protection, but calculations showed this would make the tank too heavy for its engine and transmission. They proposed upgrading the engine, but no more powerful engine was available in Japanese production. They considered redesigning the turret to incorporate better vision equipment and gun and controls, but this would have required stopping production and retooling the factory, time that Japan did not have. The fundamental problem was that the Chi-Nu had been designed within constraints that made it inferior from the start. Limited industrial capacity meant using an existing chassis rather than designing a new vehicle optimized for the gun and armor required. Resource scarcity meant accepting thinner armor and lower engine power than ideal. Quality control problems meant accepting declining standards as the war progressed. The result was a tank that was adequate by Japanese standards, but outclassed by American equipment. As winter turned to spring in 1945, the captured Sherman remained at the Army Technical Bureau facility, a silent testament to the industrial and technological gap between Japan and its enemy. Engineers occasionally returned to examine specific features, to measure components they wanted to understand better, to study solutions to problems that Japanese tanks faced. But the essential examination was complete, and the conclusions were clear. The Chi-Nu could not compete with the Sherman on equal terms. Japanese tank crews would enter battle, knowing they faced superior equipment operated by well-trained crews, supported by overwhelming industrial capacity. The tank they trusted to protect them was obsolete, and there was nothing anyone could do about it except continue preparing for the invasion, continue training, and continue fighting with whatever equipment was available when the time came. The invasion of Iwo Jima began on February 19, 1945, confirming the pattern Japanese military planners had feared. American forces landed with overwhelming firepower, supported by hundreds of ships and thousands of aircraft. The battle lasted 36 days and cost nearly 7,000 American lives, but the island fell. Japanese defenders, fighting from fortified positions with limited supplies and no hope of reinforcement, were annihilated. Fewer than 300 of the 21,000 Japanese troops on the island survived to be captured. Okinawa followed on April 1, 1945. The invasion force was even larger, with over 500,000 American troops eventually committed to the battle. Japanese defenders on Okinawa included armored units equipped with Type 95 Hago light tanks and Type 97 Chi-Ha medium tanks, the older vehicles that the Chi-Nu had been designed to replace. These tanks were committed to counterattacks against American positions and were destroyed systematically by American firepower. Sherman tanks, bazookas, artillery, and even heavy machine guns made short work of the thinly armored Japanese vehicles. The tank engagement that Japanese planners had hoped to avoid, a direct comparison between Japanese and American armor in combat conditions, occurred repeatedly on Okinawa. The results confirmed what the technical evaluation of the captured Sherman had suggested. Japanese tanks could not penetrate Sherman armor at combat ranges, while Sherman guns destroyed Japanese tanks easily. Japanese tanks attempting to maneuver were hunted down by American armor and aircraft. Japanese tanks used as stationary defensive positions were reduced by artillery and flamethrowers. By the time Okinawa was declared secure on June 21, 1945, Japanese armored forces on the island had been completely destroyed. The Chi-Nu tanks remained in Japan, positioned at various locations around the home islands. The 59th Tank Regiment, which had been equipped and trained with Chi-Nu tanks, was stationed in the Tokyo area. The 34th Tank Regiment, also with Chi-Nu tanks, was positioned to defend approaches to the capital. Smaller units with Chi-Nu tanks were deployed at other strategic locations. These tanks never moved to combat zones. They sat in their positions, crews maintaining them, and training, waiting for an invasion that would give them their only chance to prove their worth in battle. That invasion never came. On August 6, 1945, an American B-29 bomber dropped an atomic bomb on Hiroshima. 3 days later, a second atomic bomb destroyed Nagasaki. On August 8, the Soviet Union declared war on Japan and invaded Manchuria, crushing Japanese forces there with overwhelming armored and mechanized superiority. On August 15th, Emperor Hirohito announced Japan's surrender in a radio broadcast to the nation. The war was over. The Chi-Nu tanks that had been preserved for the final battle, the vehicles that represented Japan's best effort at creating armor capable of defending the homeland, never fired a shot in combat. They sat in their positions as their crews received orders to cease hostilities. The invasion they had prepared for would not occur. The battle they had trained for would not be fought. The test of whether Japanese tactics and fighting spirit could overcome material inferiority would remain theoretical. American occupation forces moved into Japan in the weeks following the surrender. Military equipment was catalogued and in many cases destroyed or confiscated. Chi-Nu tanks were examined by American technical intelligence teams, who measured and photographed them with the same thoroughness that Japanese engineers had applied to the captured Sherman. The Americans reached similar conclusions from the opposite perspective. The Chi-Nu was inferior to the Sherman in nearly every measurable category. It represented a creditable effort given Japan's industrial constraints, but it was not competitive with American medium tanks. Most Chi-Nu tanks were scrapped in the years following the war. Metal was needed for reconstruction, and demilitarization was a priority for occupation authorities. A few vehicles were preserved for study or display. One Chi-Nu survives today at the Japanese Ground Self-Defense Forces Ordnance School at Tsuchiura. Another is displayed at the Japan Ground Self-Defense Forces Public Information Center in Tokyo. These surviving vehicles are the only physical evidence of a program that consumed significant resources and represented Japan's final attempt to create competitive armor. The engineers who had examined the captured Sherman and written the technical comparison report returned to civilian life after the war. Some continued working in engineering fields, applying their technical skills to reconstruction and industrial development. Japan's post-war economic recovery would eventually create one of the world's most advanced industrial economies, but in 1945 that future seemed distant and uncertain. The engineers carried with them the knowledge of just how wide the gap had been between Japanese and American industrial capacity. The psychological burden of that knowledge was substantial. These men had devoted years to developing tanks for respectability, their nation's defense. They had worked within severe constraints, using limited resources to create the best vehicles possible. They had believed that Japanese engineering could produce equipment adequate for Japan's needs. The examination of the Sherman had proven that belief false. The Chi-Nu, despite being Japan's most modern tank, was outclassed by the standard American medium tank, a vehicle the United States produced in quantities Japan could not match. This realization extended beyond tanks to the broader question of industrial warfare. Japan had entered the war believing that fighting spirit, tactical skill, and strategic position could compensate for material disadvantages. The war had proven otherwise. Industrial capacity determined outcomes in modern warfare. The nation that could produce more ships, more aircraft, more tanks, more ammunition, more of everything, would win regardless of tactical excellence or fighting spirit. Japan had challenged the world's greatest industrial power and lost decisively. The captured Sherman that Japanese engineers examined in January of 1945 was one tank among thousands, a single vehicle in a war that involved tens of thousands of armored fighting vehicles. But it represented something larger than its physical presence. It was tangible evidence of American industrial might, proof that the United States could produce sophisticated equipment in quantities that overwhelmed any opposition. For the Japanese engineers who measured its armor, examined its engine, and studied its design, the Sherman was the moment when theory met reality and revealed uncomfortable truths. The Chinu program, conceived in hope and executed with considerable engineering skill, despite severe constraints, ended in obsolescence without combat. The 166 tanks built sat unused as the war ended, their crews never getting the chance to test whether Japanese tactics could overcome American material superiority. Perhaps that was fortunate. The battles on Okinawa and earlier islands had demonstrated repeatedly what happened when Japanese armor faced American firepower. The Chinu might have performed better than the Hago or Chiha, but better is a relative term when the baseline is inadequate. The strategic decision to retain Chinu tanks in Japan for the final defense made sense given the circumstances. Every tank sent to outlying islands was a tank lost, destroyed in battles that did not prevent American forces from advancing steadily toward Japan. But the decision also meant that the Chinu was never combat tested, never refined based on battlefield experience, never proven or disproven in the only test that mattered. The tank existed in a theoretical state, a vehicle that might have been adequate or might have been another victim of American firepower, with no way to know for certain. The story of the Chinu and the captured Sherman illuminates a broader pattern in the Pacific War, the confrontation between Japanese expectations and American material reality. This pattern repeated across domains. In naval aviation, where Japanese pilots discovered American aircraft production could replace losses faster than Japanese pilots could inflict them. In submarine warfare, where American submarines choked off Japanese shipping, while Japanese anti-submarine efforts proved inadequate. In strategic bombing, where B-29 raids devastated Japanese cities, while Japanese air defenses could not stop them. In each case, Japanese forces faced the same fundamental problem. They were fighting an opponent with vastly superior industrial capacity, an opponent that could absorb losses and continue fighting, an opponent that improved its equipment continuously based on combat experience. Japan's strategy relied on inflicting such heavy casualties that America would negotiate rather than pay the price for total victory. But America proved willing to pay that price, and its industrial base made paying it possible. The examination of the Sherman by Japanese engineers was a microcosm of this larger reality. They were looking at one tank, but they were really confronting the entire American industrial system that could produce such tanks by the tens of thousands. They were measuring armor plate and gun barrels, but they were really measuring the gap between what Japan could produce and what America fielded as standard equipment. They were writing technical reports, but they were really documenting the impossibility of competing industrially with an opponent whose factories outproduced Japan's entire economy. For the tank crews who trained on Chinu tanks but never got to use them in combat, the war's end brought complex emotions. Relief at survival, certainly. Grief for comrades who had died in earlier battles. Uncertainty about the future under occupation. But also perhaps a quiet recognition that they had been spared testing whether their training and determination could overcome material inferiority. The crews on Okinawa who fought with older tanks had learned that answer definitively. The Chinu crews were left with the question unresolved. The technical comparison between the Chinu and the Sherman that Japanese engineers conducted in early 1945 revealed quantifiable differences in armor, thickness, gun performance, engine power, and equipment quality. But the deeper comparison was between industrial systems, between economies, between nations with vastly different capacities for producing military equipment. The Sherman was not just a tank. It was the product of an industrial mobilization that transformed American society, bringing women into factories, converting automobile plants to military production, creating new manufacturing facilities on unprecedented scales, and organizing logistics networks that delivered equipment to battlefields across 2 oceans. The Chinu was also more than a tank. It was the product of an economy strained by years of war, resource scarcity, declining access to raw materials, and industrial capacity inadequate for the war Japan was fighting. It represented the maximum effort Japan could sustain, the best tank Japanese industry could produce given the constraints. That it was inferior to American equipment was not a failure of Japanese engineering skill, but a reflection of economic realities that no amount of skill could overcome. The engineers who examined the Sherman understood this, even if they could not state it openly in their reports. They recognized that the technical comparison between two tanks was really a comparison between two nations' industrial capacities, and in that comparison, Japan had no answer. The knowledge was bitter but valuable. It informed their understanding of why the war had gone as it had, why early victories had given way to steady defeat, why fighting spirit had not been enough to overcome material disadvantages. In the decades after the war, as Japan rebuilt and developed into an industrial power, the lessons of that industrial disparity were not forgotten. Japanese industry focused on quality, efficiency, and technological advancement. The nation that had been unable to produce enough tanks to equip its army became one of the world's leading automobile manufacturers. The engineers who had struggled to create adequate armor with limited resources applied their skills to creating consumer products that competed globally, based on quality rather than cost. The industrial capacity that had been inadequate for total war proved more than adequate for economic competition. But in January of 1945, those future developments were unimaginable. Japan was losing the war. Its cities were being bombed. Its navy was destroyed. Its army was being pushed back on every front. Engineers examining a captured American tank could only document the gap between what their nation had and what their enemy possessed, knowing that the gap was too wide to bridge and that the war's outcome was no longer in doubt. They measured the Sherman's armor and wrote their reports, performing their duty with professional competence while understanding that the information they were gathering would not change the war's trajectory. The Chinu tanks sat in their positions around the home islands, maintained and ready but unused, their crews trained and waited, preparing for a battle that never came. When the war ended, these tanks became relics of a conflict that had demonstrated the limits of fighting spirit when faced with overwhelming material superiority. They were scrapped, forgotten except by historians and military enthusiasts who study the equipment of World War II. The few that survive in museums are curiosities, examples of what Japan produced when pushed to its industrial limits, interesting for what they represent about the war's economic dimensions. The captured Sherman that Japanese engineers examined was probably scrapped as well, eventually. It served its purpose, revealing to Japanese technical specialists the quality and capability of American armor. After the war, it had no particular historical significance, just another Sherman among thousands. But for the engineers who measured it, who studied its design, who compared it to the Chi-Nu and understood what that comparison meant, it was the moment when hope met reality, and reality won decisively. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.